Jai Hind everyone. Welcome to the class of Microwave and Radar Engineering. The subject code is KEC074 and the lecture number is 20. In the last lecture, we have discussed about the microwave bench and the measurement for frequency. In the today's lecture, we will discuss about the measurement of insertion loss and the attenuation. Okay. Now see, when I'm saying that we will measure the insertion loss and the attenuation. Now what is insertion loss? Insertion loss is defined as the difference in the power arriving at the terminating node with and without the network in the circuit. Clear? And attenuation is the how much power is lost when I'm transferring one power from one port to the another port. Clear? So insertion loss is equal to what? Equal to reflection loss plus में attenuation loss. Now see, when a device is inserted into a transmission line, a part of PR of the input signal is reflected from the input terminal, and remaining Pi minus PR is actually enters the network, which is attenuated due to the non-zero loss of networking. Clear? Now if I say this is a device, I'm transmitting some information, that is Pi, and some part of the information is what reflected back by this device, and that information is, that power is equal to what? PR, and remaining part is transferred to the towards the load side, or you can say at the out, will obtain the at the output of this device. Clear? So insertion loss is defined as the difference in the power arriving at the terminating load with and without the network in the circuit. So PO minus में PI equal to what? PI minus में PR upon में PI multiply में P naught upon में PI minus में PR, means this one is P out by P in. If you will say that P out by P in equal to what? PI minus में PR upon में PI multiply में PO upon में PI minus में PR. Now see, the actual insertion loss is equal to what? P naught by Pi, and that is equal to, if I want to calculate it in decibel, that is 10 log of P naught upon में Pi equal to dB. Now what is reflection loss? Reflection loss is what? How much power is reflected back? That is 10 log of 1 minus में PR upon में Pi. Or you can say reflection loss equal to what? 10 log of Pi minus में PR upon में Pi. Clear? Means you will see how much power is transferred at the output divided by Pi. That defines the reflection loss. Therefore, and we know that the reflected voltage divided by input voltage. That is, if I say reflected voltage divided by incident voltage, it defines the reflection coefficient, and square of this reflection coefficient, that defines the reflected power divided by incident power. Therefore 1 minus में PR by Pi is equal to what? 10 log of 1 minus में reflection coefficient. Now see, as we know that the standing wave ratio is equal to 1 minus में reflection coefficient और 1 plus में reflection coefficient, therefore I can say that reflection loss equal to 10 log of 4s, means 4 multiply में standing wave ratio upon में 1 plus में s का whole square. Now what is attenuation loss? Attenuation is equal to what? 10 log of PO upon में PI minus में PR. means you will say that if I say this is a device and some power is reflected back by this PR. So actual input of this device is equal to will be what? Pi minus में PR, and how much power is obtained at that is PO upon में Pi minus में PR, that is attenuation loss equal to 10 log of P naught upon में Pi minus में PR. Or you can say that if I say this is a device and this is a if I say this is a device under test. Now see, if I say if I am providing some input Pi and some power is reflected back by this one, that is PR. So ultimately device under test having what? Exactly input is equal to Pi minus में PR, and the output if I say this is PO, that PO minus Pi minus में PR, that defines the attenuation loss, and insertion loss is directly equal to P upon में Pi. Therefore return loss is equal to what? 10 log of PR upon में Pi. How much power is returning back? It is PR upon Pi, that is equal to 10 log of PR upon Pi, and this is equal to what? 10 log of reflection coefficient का whole square, and that comes out to be 20 log of reflection coefficient. Clear? Now similarly, how can we measure the steps for or methods for measuring the attenuation? First method is power ratio method, and another method is RF substitution method. Now attenuation, I have already told that attenuation is equal to what? 10 log of P in by P out, that is ratio of the input power to the output power, and input power is equal to what? To this device under test, input power is Pi minus में PR, output power is this one. Okay. Now see, attenuation will be equal to 10 log of P in by P out, and if I set attenuation loss, that is equal to P out by P in. Therefore P in equal to what? P in is what? Input power, and P out is your output power. Now see, first method is power ratio method. In the power ratio method, now see, this is the first step 1 in which I have provided setup, microwave bend setup, microwave source plus attenuator, then frequency meter, then slotted line, then termination, crystal detector, thermistor, and the power meter. In the first step, output power will be measured through power meter when there is normal setup, means when there is a normal setup, and from this normal setup I will get what? Input power, means the power which is coming from the microwave source, and the output of the power meter defines what? Input power which is getting at this slotted line terminal and this one. Now see, if I want to calculate the attenuation of what? Attenuation of device, so I will just connect the device whose attenuation is to be measured. Now I will check what? Output at the power meter of the output, that is equal to will be what? P naught. That P naught by P in defines the what? Attenuation. Clear? The ratio of these power when compared gives the value of attenuation. Now see, the next method is what? RF substitution method. In the step 1, in this you will see, first similarly, network whose attenuation is to be measured is to be placed between what? Frequency meter and the slotted line, and the output of the power will be measured on the power meter. Clear? In this I will get what? Some power which is measured, and in the next setup I will just replace this device under test with the variables precision attenuator. Now if I say, if I am getting a power meter from the power meter, I am getting a value of what? 20 milliwatt. Clear? So then in this I will just replace this device under test with the what? Variable precision attenuator. And the power meter, let's say if here the power meter is what? If I say the output of the power meter at this device is 10 milliwatt. So here, to obtain the same power, when the device which is to be measured, power meter is 20 milliwatt, and then when device is standard, here the variable attenuator is the PO is 10 milliwatt. So here I will just what? Vary the variable precision attenuator so that the output at P0 changes to what? P0 equal to 20 milliwatt. And from here, when I'm just varying this precision attenuator, then I'll just measure the attenuation, and this attenuation will be equal to the attenuation of this device. See this one, the output power of the microwave device is measured with the network whose attenuation has to be calculated, and then in the next step, the output of the power meter is measured by replacing the network with a precision calibrated attenuator. In that third step, I'll just vary the variable attenuator so that output of this power and output at this power will be same. Now this attenuator is adjusted to obtain the same power as measured with the network. Clear? Now the next we will discuss the next topic is the Vswr meter. Vswr meter is what? It just calibrated to a DC voltmeter detecting what? Rectified DC voltage from the crystal diode detector. It can measure the Vswr as well as the what? Voltage. And from the Vswr meter, I can calculate the reflection coefficient from the Vswr meter. Now see, by moving the crystal diode detector, carriage of the slotted waveguide can be measured by noting the Vmax by V minimum defines the standing wave ratio. As Vswr meter, what? Vswr meter is the meter which shows the value of what? Which shows the value of standing wave ratio, and standing wave ratio is equal to what? Vmax by V minimum. Clear? So Vswr can be directly measured on the scale of V meter by calibrating the adjacent gain knob to show the maximum scale deflection of unity SWR. So while calculating the Vswr from the Vswr meter, I'll just have to vary the what? Gain, or I'll just vary the slotted line position so that maximum scale deflection will be obtained and on the Vswr meter. Now, when I have moved the slotted line section so that the maximum scale deflection will be obtained, now I will just also move the detector carriage to minimum value on the meter, and this reading on the meter, Vswr meter, defines the what? Value of the Vswr. Now see how this one. Now see this one. This is a Vswr meter or scale, and this figure shows the Vswr. In this is a Vswr meter scale. You will see here that first one is this scale, another one is this one, third one is this one. First one shows what? Expanded dB scale. In decibel it is showing the scale. Now it is showing the what? This scale showing the what? Vswr meter expanded, means for the low value of SWR. This value shows the for the VSWR scale, that is in the nominal value. This is shows in the dB scale, and this shows the voltage scale. Clear? Now see, if we read the voltage at these two locations, the ratio Vmax by V minimum will be same as the VSWR meter on the this one. Now see this one. First, we will move the slotted section or crystal detector in such a way that the maximum deflection will be obtained at the VSWR. And on that position, I'll just measure the position of the slotted section. Clear? Now I will just move the position of the slotted section to some value so that minimum value will be obtained. And when I'm getting the minimum value on the VSWR, that shows the exact value of the VSWR. Now see this one. Measurement of VSWR. A mismatch load always defines the resulting in the standing waves, and the ratio of maximum to the minimum voltage defines what? VSWR, that is equal to 1 plus my reflection coefficient upon 1 minus my reflection coefficient. And I have already told you in the previous lectures that its value varies from 1 to infinity. And this reflection coefficient is equal to what? Incident reflected voltage upon my incident voltage, or you can say under root of P reflected by P incident. Now see this one. When terminating voltage is not equal to matched terminal, Z0 means characteristic impedance of the transmission line. When ZL is not equal to Z0 is connected to a transmission, the standing waves are produced by. Now see what is the procedure by inserting a slotted line system in a line. Standing waves can be traced by moving a carriage with a tunable probe along the line. Means the slotted line section, there is a crystal detector or tunable probe. This tunable probe has to be varied in such a way that maximum deflection will be obtained on the VSWR meter. And the next step is what? Now I will vary the position of this slotted line section so that the minimum deflection will be obtained on the VSWR, and at that time the exact value on the scale of the VSWR meter defines the VSWR. Now see, first method is measurement of low VSWR meter when the S is less than 10. Here VSWR less than 10, therefore you can say that the slotted line carriage will be obtained. I have already told you. The measurement of low VSWR can be done by adjusting the attenuator to get a reading on the DC millimolt meter, which is a VSWR meter, and the readings can be taken by adjusting the slotted line and the attenuator in such a way that the DC voltmeter shows a full scale deflection as well as minimum reading. Now this I have already told you: microwave source, attenuator, slotted line section, crystal detector, and the VSWR meter. Now see this one. First see this one. This is a SWR Vmax upon V minimum. Vmax is this one. V minimum is this value. Vmax by V minimum shows the SWR, and I have to move the slotted line in such a way that maximum will be obtained and the minimum will be obtained. These are the slotted line probe positions. Now next one is the when I'm just measuring the VSWR whose value is what? Greater than 10. The method which is used for calculating the VSWR greater than 10 can be obtained by the double minima method. in the double minimum method, what? Minimum reading at the minimum value is taken, and again I'm just using the another minima method. Means there will be two minima will be defined, and in this section you will see we use the slotted line to locate the minimum point D0 and read the minimum voltage value, that is V minimum. Now then we locate the position of these 2 points D1 and D2 on the left and the right of this V minimum. That defines the root 2 of V minimum equal to 1.414 of V minimum. And on just squaring this power, you will get what? D0. Now see this one. From this position, you will see this one. This is double minima method. When VSWR is greater than 10. Now see this one. In this, first I will just move this slotted line carriage in such a way that minimum deflection will be obtained on the minimum voltage will be obtained on the CRO. Clear? That position is known as on the CR, that is known as the D0. Now I will just move this slotted line in such a way that 1.414 root 2 of V minimum will be obtained, and at this it is known as that position is known as what? D1. And similarly I'll just move the slotted line section in here. It is in the left position, and now I'll just move the slotted line in the right position so that minima root 2 times of minima value will be obtained on the CRO or the wave of the CRO. Now you see that position is known as the D2. So therefore VSWR will be equal to what? Lambda G upon में pi into में D2 minus में D1, and lambda G is equal to what? Guided wavelength. And this guided wavelength is equal to, will be what? Equal to, for the dominant mode, this guided wavelength TE10 it is equal to 2A. Clear? So here you will see that this is D1, this is D2, and VSWR equal to will be what? Equal to lambda G upon में pi into में D2 minus में D1. Clear? So in the today's lecture we have discussed about the Vswr meter and the measurement of insertion loss and the attenuation, the procedure to calculate the Vswr